What's going on, everyone? My name is Johnny Bandon and I will be your CCNA instructor for this CCNA video series. And in this video, we're going to go over another important IP service, and that is DHCP, the Dynamic Host Control Protocol. So DHCP, when you're in a network with IPv4, is going to be used pretty much everywhere. If you work on the enterprise, if you're a LAN administrator, you're going to be dealing with DHCP. Now, whether that DHCP service is running at your iOS, meaning your Cisco router or multi-layer switch, or an actual DHCP dedicated service on let's say a Linux or a Windows server, typically Windows, you're going to be dealing with DHCP. And in later sections, we'll actually go over DHCP snooping and like security for DHCP. But in this section, we're just going to go over the configuration, the operation, and of course the why we need DHCP. So let's go over our agenda here. So the first thing we're going to go over, like all of our sections, just a quick overview of DHCP, what it is. What is the Dynamic Host Control Protocol? And then we're going to go over the why. Why do we need DHCP? What is the true purpose of dynamically allocating IP addresses, and why would we want that functionality on our systems and on our networks? And then we're going to go over the operation. So essentially the behind the scenes of how DHCP works. What is the DOR request, or really the acronym DOR? How does my client dynamically get a IP address and other information from the DHCP service? We're going to go over that operation. Then we're going to go over the different options you can configure with DHCP. Because this is such a versatile application or technology, DHCP, we've actually found ways for DHCP to also help us out with other administrative burdens on our local area networks, like the pre-execution environment, booting up phones, and a host of other things that DHCP can help us with for our clients or our endpoints. And then we're going to go over DHCP relay. So what happens when your DHCP server doesn't sit on your LAN? What if it's geographically dispersed, or it sits outside your local area network and you have to send a DHCP packet across your WAN connection? We're going to teach you how to configure that as well. And then we're also going to go over the configuration and verification of DHCP on iOS. So I'm not going to show you what a Windows Server DHCP deployment looks like. We're just going to go over DHCP services on the iOS. Awesome. So with that being said, let's go ahead and get started. Let me make this a little smaller and move my face out of the way. Okay, so DHCP overview. So the Dynamic Host Control Protocol is going to allow clients on your LAN to receive their IP addressing information automatically. So these computers right here, whether they sit on VLAN 10, 20, 30, doesn't matter, this VoIP system is going to be able to send a request to a DHCP server, and in this picture we have a dedicated server, but it can also sit here on the router in that iOS system to dynamically get an IP address. Because as you know, on our computer systems, or anything that wants to talk to the internet on the network needs an IP address. We need that layer 3 addressing, that connectivity. So when we deploy endpoints onto our system, do we want to statically assign all the endpoints an IP address and manage that ourselves? Or do we want a protocol that we can deploy to do it for us? Because imagine this small network here. Yeah, it would be pretty easy to go in and statically configure IP addressing, but what if now we have 200 computers? And then we have Internet of Things devices. Then we have printers. Then maybe we have video teleconferencing machines. There's so many things that need IP addressing nowadays to work, to function, to communicate within our networks, that DHCP is really the only option we have for IPv4. And then DHCP servers can sit on-prem, meaning, let's say this is all one network. Let's say this DHCP server sat out here at the LAN and actually belonged to the same subnet of this computer. That's on-prem, but they can also sit off-premise, meaning that this router maybe is a spoke that's connected to an HQ router that's going to host a local data center for the entire enterprise. That DHCP server can sit across the WAN, and these computers can still do a request all the way to this DHCP server. That is possible. DHCP can also be configured on the iOS. So our actual router here can act as a DHCP server. Now, a lot of times students ask me, when do you want to deploy iOS DHCP or dedicated DHCP server. And I've looked through documentation on Cisco and read forums. It really just depends on your engineering and how you want to engineer your network. So in my mind, when you want to use a dedicated DHCP server is when you have multiple subnets, you have that dedicated maybe local server farm already there for you to use the compute and storage, and you just want a dedicated service to service the thousands of maybe DHCP requests you may get. So we're talking a kind of a medium to large size business. Maybe you want to run that dedicated DHCP service on a server, and that could be a VM. On the iOS, it does offer you convenience and cost effectiveness to just have what we call like an ISR, which is an integrated service router. That's what these small to maybe more mid-sized businesses getting into that mid-sized business are going to use. For example, a small company that just is on a strip mall, they maybe just have at most 10 computers for maybe some salesmen, maybe it's a retail store. You're just going to have one router probably sitting in a little rack, maybe up on a wall, maybe in a comms closet, and you're going to have maybe a switch, and you're going to have access points, and then all your endpoints that are connected. Well, are we really going to buy extra hardware, like maybe a server to connect and just run a single DHCP service for our possibly one or maybe two subnets we have in our small business? Probably not. It may just be easier, and it is easier to run DHCP at that router right there. And that's why Cisco calls these integrated service routers, because essentially this router can do a lot of the functionality that maybe in a bigger business you'd have dedicated services and servers for. Another thing those ISR routers can do is like VPNs. So instead of buying a VPN or firewall concentrator, the ISR can do your IPsec. It can do your SSL VPN. You don't see this a lot anymore, but I'm sure in some cases it could also do what we call Call Manager Express, can also do the collaboration if your small office needs Cisco VoIP phones configured. So DHCP can sit at the iOS, and for the CCNA exam, we need to learn both DHCP and the iOS and what you do when a DHCP server is configured off-prem and away from the local area network. And this is going to make more sense when we get into the DHCP operation, because our clients are sending DHCP requests via broadcast. So really, if a DHCP server is not part of the same subnet as this computer here, let's say it's 1.1.1.0/24, and this DHCP server sits on this subnet. If this computer is sending a broadcast message for a DHCP request, it's only going to be sent within that subnet. So we do need some sort of technology or way to relay that message over to the DHCP server, and we're going to go over that. Okay, so why we need DHCP, and again, sometimes I do get ahead of my slides, but DHCP is going to relieve that administrative burden of statically setting IPs on maybe the hundreds or thousands of client devices in the enterprise. And then when you offer other services, like you need your computers to know their DNS IP addresses. Maybe you need some TFTP services that need to be run automatically. Or like I said, that pre-execution environment. What that is allows a computer to pull off an image or a baseline over the LAN instead of you, the IT administrator, going up with maybe a disk or a USB drive to install an image on a brand new computer coming into your network. So that pre-execution environment can be done from, like, let's say a Microsoft SCCM deployment, or maybe we just do a Windows deployment server. And there may be a lot of different options out there that you on the internet know. I'm in networking, so I've never had to really deploy these services, but help with the network side of things. So on your DHCP pool, you can put all these other options on it instead of just doing regular IP addressing. Now, as we can see here, we have our VLAN 10 network. We're going to tell our clients about the default gateway. We're going to assign them an IP address within this network. And then we also give them their DNS servers. And then we're going to put a time on that DHCP lease, meaning, hey, after 7 days, we want you to renew and try to get a new IP address. And then we have this option 67, which is going to be used for that pre-execution environment I was talking about, where this computer could possibly pull an image from the LAN, reaching out to this Windows deployment server. And here we put that IP address to point that computer to the correct IP address of that Windows deployment server. And then DHCP Operations. So we kind of know what DHCP is, why we need it, and what the purpose is. Now, how does that client actually perform that DHCP request? What actually goes into it? So the first thing that happens when a client boots up, it goes through its layer 2 connection, right? It gets connectivity. And then if it's DHCP enabled, it's going to send what we call a discover packet. That's the first packet that goes out, and it's going to be a broadcast packet. And then there's 4 total steps. And we call those 4 total steps in requesting an IP address DORA. And that's the entire DHCP operation. If you know this acronym DORA, which we're about to go over, that is DHCP operation in its totality. So let's go over that. So DORA stands for Discover, Offer, Request, and Acknowledge. And during this communication between client and DHCP server, we're going to essentially connect to that DHCP server and get IP addressing information from him after that A. So let's break down this DORA request a little bit more. So DHCP version 4 messages are going to be encapsulated within the UDP protocol. So that's a long way to say DHCP uses UDP. And then we have 2 port numbers that we're going to use. It's going to be 68 and 67. So from the client, it's going to be source port 68 and destination port 67. And then you're going to flip that when it comes to the server talking to the client. So the server's source port's going to be 67 and the destination port's going to be 68. And here's the DORA request we were talking about. So let me change the color on my pen here. So the very first thing in a DHCP operation, and I have that v4 here because we're talking IPv4. Not like there's so many different flavors or versions of DHCP that have come out. There has been, but that v4 stands for IPv4. So the first message that's going to go out is called a DHCP Discover message. And when we work at the Wireshark capture, you're going to see this process as well. And we're going to have, this is going to be a broadcast message. And within that DHCP broadcast discover message, which is the D in our DORA, it's going to say, hey, anybody out there, I would like to request an address. So this is sending a broadcast message. So let's say this computer sits on 192.168.1.0/24. The destination IP address in this packet is going to be 192.168.1.255. And if there is a DHCP server sitting on that subnet that can listen to those broadcast messages, they are going to send a unicast message back to this client. Because remember, that IP packet that's going to be sent out is going to have the source IP of this guy. It's going to send a unicast packet back out saying, I am the DHCP server, and I do have IP addressing I can give to you, as well as other options if you're requesting them. Once that client receives that offer, that DHCP offer message via unicast, it's going to say, great, I can accept that IP address offer, and then I also need maybe some other options, like we need a Windows deployment server, maybe we're a VoIP phone looking for configuration. And that's still going to be a broadcast message though. It's still going to be a broadcast out. So the destination IP is still going to be that 255. Again, that DHCP server is going to hear that request. Now we have a DHCP request, which is the R in our DORA. This offer is the O in DORA. And say, awesome, I acknowledge that, and I'm going to talk to you directly, client, with the unicast message and give you your IP addressing. And that's going to be the A in DORA. So you kind of see DORA is very easy to understand. It's discover, offer, request, and acknowledge, right? D for discover, O for offer, and I'm going to put little parentheses here. This is from the client. The offer is from the server. R is request, and this is from the client. And then A, acknowledge, I'm just going to put ACK. That is also from the server. So clients and servers do this little dance, they do DORA, and now the client has its IP addressing. So let's actually look at a DHCP packet or the message format. So of course this packet's going to be encapsulated, right? So we're still going to have our Ethernet header, our IP header with the source and destination address. But if we look in here, in the DHCP packet, it's going to have like your server address, your IP addressing. It's going to have the gateway IP address that you need to know about. It's going to have this server name here. What that means is just actual like DNS, right? Or sorry, excuse me, the DHCP server name. And then any other options. So these are the options we're talking about. So if we need to know the information of a Windows deployment server or maybe a call manager so our VoIP phones can be configured, it's going to be down in there. And again, we're going to look at a Wireshark capture of this, so stay tuned if that doesn't make much sense. Okay, now let's go over the DHCP options. So DHCP does allow you to advertise different options to your client devices, meaning if your client needs something specific. A great example of this is Cisco VoIP phones. Cisco VoIP phones need to use TFTP when they boot up to get their configurations or their boot file from a call manager server. Now we're talking Cisco, so that's the environments I worked in. So that's called a CUCM, Cisco Unified Call Manager server. And that server is going to have all the configuration files for that phone. They do that via MAC address. That's how they recognize the phones and by the model type and all that. It's going to be a profile essentially for that phone, right? Well, this phone needs to do a TTP request to get its configuration from that call manager. Well, if we're not statically setting that IP address to the call manager, we run DHCP. On our DHCP server, we need to configure what's called an option 150 address. And that option 150 address is going to be the IP address for that call manager. So when this phone does a request to its DHCP server, it's going to request that as well during its R, right, of the DORA process. It's going to say, hey, I also need an option 150 IP address. So let's say in this router, we didn't have that option 150. This phone would never learn about its call manager's IP address. It can never pull that configuration via TFTP. So it's both things. This phone automatically knows, there's nothing you got to do. Out of the box, it's going to know it needs an option 150 address. So if you're set up on your iOS device a voice VLAN, and you have to set a DHCP pool for that subnet of all the voice VLAN IPs, you need to remember to put that option 150 address, which is the IP address of your call manager or the server that's configuring your phones. And then we see here different options like 66, 67, which allow a client to be part of that pre-execution environment like I was talking about earlier. So there are many other options you can configure, and a lot of times this is on a case-by-case basis. The ones I've seen in the enterprises I've worked on have always been for that Pixie environment and call manager. That's when I've configured DHCP services or pools on an iOS device. Those are always the options you got to think about. And if you're ever coming into an environment and they have you set up a new DHCP pool for, let's say, a spoke somewhere, spoke site, it's something you got to talk with that senior network administrator. Say, hey, what options do we have in our DHCP pool? And that's just kind of knowing the architecture and how your services run in the enterprise you work in. Now let's go over relay. So when we went over DORA, we know the client's initiated. That first D stands for what? Discover. That DHCP Discover packet is broadcast. Meaning the only devices that are going to hear that broadcast are devices that sit within that subnet. So let's say for VLAN 20 here, that DHCP Discover is only going to be heard from devices that sit within the, it says up here, 172, 192.16.1.0/24 network. Or actually, that's the IP helper address. Just forget, let me back out of there. So let's say VLAN 20 is 192.168.20.0. This broadcast is only going to be heard within that subnet. Well, as we can see here, it looks like we have an ISP connection. Let's say this is R1. Our DHCP services are sitting beyond VLAN 20's local network. The DHCP server is not in the LAN, it's not part of that subnet. So how is this client here going to get its IP addressing via DHCP? Well, what we need to configure is a DHCP relay. So under the interface that's acting as a default gateway. So let me explain this. So in this environment, we're obviously running router on a stick because you see our sub interfaces here. So we have interface gig 00.20. This is the default gateway for all users in VLAN 20. And all users in VLAN 20 are going to send a DHCP discover message, which is broadcast. When that interface hears or listens to that broadcast and it receives it, we need to tell this interface to send that DHCP discover message to the DHCP server. We do that with something called an IP helper address. When we configure that IP helper address under the interface that is acting as a default gateway for our subnets in our LAN, it's going to take that broadcast and it's going to turn it into unicast and send it off to that distant DHCP server. So now that discover packet is going to reach the DHCP server, but it's going to be via unicast, and the source IP will be this guy right here, or the source of that IP packet, right? This DHCP server is then going to send the offer message back to this interface and say, hey, we do have an offer, or I can offer IP addressing. So pretty much the door process now runs as normal. And then when this user does a request, it's the same thing. We know that in the door process, a request message is typically, or it is, broadcast. Again, the default gateway interface, since it has this IP helper address configured, it's going to relay that request message via unicast over to the DHCP server. That's how we configure DHCP relay on our iOS devices. Essentially, it just changes that DHCP discover and request messages into unicast to send to that distant DHCP server. And again, you notice you need it under every subnet or default gateway that belongs to your environment. So if we have VLANs 10 through 20, and we have 10 sub-interfaces, each sub-interface needs that IP helper address command because it's listening for broadcasts within that specific subnet or network. All right, now let's go over DHCP configuration. So on the Cisco iOS, a DHCP server can be configured. And this is how we do it. So it's a couple commands. It's just IP DHCP pool from global config, and then you're actually going through and configuring the IP addressing. So here we have, let's say, a data subnet or VLAN. As you can see here, we're obviously on a multi-layer switch. This command right here is going to define the network address. So this is the network we're going to be assigning IP addresses. This is going to be the default gateway. These are our DNS options. And then you see under here our voice. We're going to configure it the same way, but then down here when we configure our DHCP options, and again, this is for our voice VLAN, so for our VoIP phones. On our data pool, we put that option 66 in there so we can have that pre-execution environment image over the LAN. And then our voice pool, we ensure we have that option 150 address so our phones can reach the Cisco Unified Call Manager so they can TFTP their configurations and their phone profiles. And then with that relay configuration, as we see here, we are just going to put the IP helper address under the default gateway on our multi-layer switch here. So we have interface VLAN 10, the SVI for VLAN 10. We need to point to the DHCP server over here so that any broadcast messages, DHCP broadcast messages we receive, we know where to send them to via unicast. And then you see right here in this little environment I have, you see this device? This is going to be a VTC machine. And this could easily, for this example, have been a printer as well. Some devices in your network you don't want to be configured for DHCP. So what do we do in that scenario? And I'm going to go over this in the lab as well. So for your printers, you typically want a static IP address, and why? Well, maybe you want to resolve that printer via hostname. So maybe your DNS server, you need a static IP address to resolve that printer's hostname. Or maybe your users that map to that printer, you don't want that printer changing IP addresses maybe every 7 days due to that DHCP lease time. There's a lot of different reasons why a printer needs a static IP, but essentially that's how you architecture it out, right? Or that is the architecture. Printers should have a static IP, so when you map to it, when you deploy print server, or you want to resolve it to it via hostname in your enterprise, you need that IP address not to be changing. A VTC machine, same deal. VTC machine sometimes won't have a phone number. Maybe you want to initially just have an IP address that connects VTC to VTC in your collaboration. You need a static IP. It can't always be changing. So it's easy enough to assign the static IP address to the device, right? Just get into the printer's GUI or the VTC's GUI. But at the actual DHCP pool that you configure, and whether that be on your iOS or your DHCP server, you need to exclude that IP address from the pool because you statically assigned it to one of your endpoints. And we'll go over that in the labs as well. Oh, there's this. Cool. So here's how you do it, right? So there may be times, again, like I just described, when you need to exclude an IP address from the pool for assignment. So it's just simple as this, IP DHCP excluded address, and you can pick out a single, or this allows you to do a range. So this isn't just exclude this IP and this IP. This is saying exclude this IP through this IP. So that means the IP address .52, 53, 54, and so on will not be a part of the pool for dynamic assignment. And now let's go over some verification. So again, this is all going to be done on the iOS. So show IP DHCP pool. You can see the IP address range. You can see how many are leased, how many IP addresses are excluded, and then the total IP addresses in that DHCP pool that you configured. Then same thing for this pool down here. And again, this will show you every single pool. If you want to just look at, let's say, your data pool, because that's what you may be having issues with on your user's data VLAN, or that subnet, you can actually specify just a pool you want to look at by its name. More verification, so show IP DHCP binding. So this will show you the actual IP address that's assigned to a device with its MAC address, and then when it's going to expire. So again, kind of good commands for troubleshooting, like, okay, this computer, let's see if it's in our binding pool. And that's going to be only verification commands I show you. There's one more that I'm going to go over during our labs, and that's the clear command, where you can actually clear DHCP conflicts or bindings, which sometimes you'll need to do in your environments. All right, awesome. So that's going to be it for this DHCP lab, or excuse me, not lab, this DHCP lecture. And I want to thank you all for viewing, and stay tuned for our next 2 DHCP labs. Thank you.